Your home's electrical system begins at the transformer on a utility pole. The wire that stretches from the transformer on a pole to your house is known as the utility service drop. The farther the transformer is from your house, the more likely there is a reduction in your optimal voltage. You can use a multimeter to verify the voltage at the service panel. This voltage should never be below 10% of the nominal voltage. For example, if your nominal voltage is 120 volts, any reading less than about 110 volts should be addressed. Up until the utility drop reaches the house, the installation and maintenance are the responsibility of the utility company. The minimum clearance from the ground is about 12 feet, and the cables are usually installed this way. However, ice storms and fallen trees commonly pull down utility lines. In addition, if there is a deck built or landscaping is built up, clearance issues can arise. Use common sense. If you are within reach of the cable, or using a conductive ladder, the cable should be nowhere near you. The utility drop should not be too low to the roof until it reaches the attachment to the house. A cable that brushes the roof or trees will lose its insulation, can possibly electrocute someone on the roof, or can present a fire hazard. The same rules apply to the telephone service drop as well. If you see that your telephone line is lying on the utility service drop, and you constantly hear static when talking on the phone, this static may indicate that the telephone drop has shorted into the bare neutral of the utility cable. Look to make sure that the insulation is intact to the house, as well as any outbuildings. If there are any bare sections, call the utility company for maintenance. Once the cable reaches the house and splices into a triplex of 3 cables, the utility cable changes names and responsibility. From here to the inside of the house, it is commonly referred to as the service entrance cable, or SEC, and is the responsibility of an electrician. Here we see a service entrance cable with some exposed wires that need addressed immediately. The SEC should be securely attached to the house, not pulling away. Your cable may be attached to a masthead that extends above the roof. This was done to obtain a safe clearance. The masthead should not be bent because the cable inside could get pinched and short out. There should also be clamps against the building every few feet. Sometimes, a cable is taken around the corner of a house or is stuffed behind a gutter. This is very dangerous because a sharp edge can expose the hot conductor, and someone touching metal siding or a gutter and downspout can be electrocuted. The grounding system of your house should be through a minimum 5/8 of an inch diameter galvanized or copper-clad rod in the ground. However, some houses could be using a rebar in the footer as a ground medium. The electrician should be able to determine if your house is properly grounded. A big copper wire that goes from the service panel to a clamp on the rod is what grounds your panel. The meter base should match the fuse box or circuit breaker panel. A small circular meter base normally feeds a 60 amp fuse box. A larger fuse box inside the house would require an upgrade in the SEC and the meter base, but unfortunately some people want to avoid permits and don't safely upgrade. A small square meter base usually feeds 100 amp service. A larger rectangular meter base usually feeds around 200 amps. If you suspect an illegal upgrade, have an electrician check it for you. You should see at least 2 20 amp appliance circuits and at least one 15 amp lighting circuit for every 500 square feet of house. An overloaded panel will be obvious. There will be several wires under one screw. You are typically allowed only one wire under a screw, but there are exceptions with certain 15, 20, and 30 amp breakers with a special design. There should not be any wire tap off the main circuit breaker lugs. However, 2 wires feeding into the main lugs that are connected to a small arrestor mounted on the panel indicate surge protection. Fuse boxes sometimes have an illegal tap as well. usually off of the 240-volt water heater circuit. If your panel is jam-packed with wires, be especially careful taking the cover off or placing the cover back on. You do not want any wires to get pinched between the cover and the box. An electrician will be familiar with your local codes and can identify overcurrent. This happens when an undersized wire is connected to an oversized breaker. Examples would be kitchen, utility room, and bath receptacles. Local codes vary, and some wiring may be grandfathered in. Now let's talk about the different kinds of breakers. A single pole connects to one pole or hot bus on a panel. This provides power to 120-volt appliances. A double pole is twice the size of a single pole and attaches to two poles or hot buses in the service panel. Double poles provide power to 240-volt appliances. There are also 2-in-1 breakers that have two half-size singles in the same space as a single pole. Quads are available as well and have 4 breakers in the space of a double pole breaker. The latter two are often used illegally in standard panels. They actually require a specially formatted panel that some homeowners are reluctant to install. Another thing to look out for is 2 single poles being used as a double pole or 240-volt breaker. If you can trace both wires back to the same cable, this is wrong. I'm sure at some time you will come across a damaged breaker, an example being a broken handle. The first clue that something is wrong with the breaker will be a discoloration of the wire that connects to it. This is normally a loose connection that overheats. When the breaker fails, the excessive electrical load can burn wiring, destroy the breaker, and arc onto the tab. Once a tab is burned, it can't be used again. Installing a new breaker on a burned tab is dangerous because the burned tab may heat up and cause further damage or even fire. Wires inside the panel are supposed to stay within the gutter area along the outside edges. An extremely dangerous situation involves wires that cross the face of the panel, especially if they are bare. Look out for exposed hot conductors and wires that have their insulation split. Aluminum wiring is not widely used anymore because of the complications of wiring it to receptacles or switches not designed for aluminum. Trouble signs or warm cover plates on switches or receptacles, any strange odor near the receptacles, or a periodic flickering of lights. A certified electrician can verify proper wiring or aluminum to copper splices. Many labels on lids or metal lugs say you can use copper or aluminum. However, using both is not allowed. Correcting these problems doesn't require a total rewire of the house. Receptacles marked AL/CU just need to be replaced with CO/ALR. You could also keep the existing receptacles on light fixtures by having a professional place copper pigtails on the ends of the aluminum wires and devices. If you see any splices with wire nuts, take a close look for signs of burning or overheating. A bonding strap is also required, though usually hard to see. This connects the neutral or grounding bus to the metal frame of the panel and adds the frame to the grounding system so that the frame cannot become a conductor if a hot wire touches it. The ground connection to the water pipes must be visible and touchable. Use your multimeter to perform a voltage check. You should get close to 0 volts. Put one probe on the grounding or neutral bus in the main panel, and the other probe should touch the copper or galvanized water line. If the pipe is too far away, you can use alligator clips. Or, if an outlet or receptacle is near the water line, touch the red probe to the white wire and the black probe to the pipe. Do not touch the black wire in the receptacle because that is a hot conductor. If you cannot find a ground wire and the pipe is in reach, do not touch it. This pipe could be conducting up to 120 volts. And do not ever touch metal water lines while the body or feet is in contact with moisture. A sub-panel is used to minimize the number of wires needed to reach across the entire length of the house. The sub-panel is fed from the main panel and is easy to install incorrectly. The most common problem happens when an installer uses a standard service panel that doesn't have isolated buses. In a sub-panel, the neutrals must be isolated from the grounds on different buses. Otherwise, you will have parallel current paths between the sub-panel and the main panel, and there will be neutral current flowing through the ground wire. A 60 amp fuse box with 4 plugs worked very well when it was introduced. However, in today's world, this is not adequate and should be at least 100 amps. If you have a fuse box, you will probably see a large gray wire entering the top of the box. This is a stove wire. The common problem with older fuse boxes is that sometime someone may have replaced a fuse with a larger or smaller one, and now the wire gauges aren't protected like they should be. For example, a 15 amp fuse protects a 14 gauge wire, and a 20 amp fuse protects a 12 gauge wire. Any fuse with more amps installed will not give adequate overcurrent protection and may lead to fire. One remedy you should consider is called a fuse stat. Mismatching cannot happen with these because each amp fuse has a different thread size and a specific current capacity. Also look out for any circuits that are doubled up. This is not allowed. The average room has at least one receptacle per wall. Larger rooms should have receptacle space so that every horizontal point on the wall is less than 6 feet away. Look at your outlets. Are there 2 or 3 slots? Remember that the third slot is the grounding connection for appliances with a metal casing or appliances not double insulated. If you only have 2 slots available, you can still safely use a 3-pronged appliance plug when you use a 2-slot receptacle that has an adapter. The kitchen should have 20 amp appliance outlets located every 2 feet above the counter. Bathrooms should have at least 1 outlet, and no switches or outlets within reach of the shower. All rooms, stairs, and hallways should have 3-way switching. Hallways should also have at least 1 outlet. All receptacles should have a cover as well as any splices. Switches that interrupt the electrical flow in a 110-volt circuit control light fixtures. However, if your light fixture can be controlled by 3 or more locations, it may only be running on about 24 volts. This circuit usually includes a transformer and an electrically operated switch called a relay. These are usually mounted somewhere near the fixture. If your house has this system, make sure to stock up on relays just in case.